Hello students, in video number 19 we have studied introduction of bases and classification of bases. In this video we will study preparation and properties of bases. First let's start with preparation of bases. There are various methods to prepare bases. First one is from metals. Metals react with oxygen and results in the formation of oxides which are bases. For example, sodium when react with oxygen, it forms Na2O, magnesium plus O2 gives MgO, and all these oxides are basic in nature. Second method is by the action of water on reactive metals like sodium, potassium and calcium, that is, all the metals which are present above hydrogen in the activity series. For example, sodium reacts with water, results in the formation of NaOH along with that hydrogen. Potassium combines with water forming KOH and hydrogen. Ca plus H2O gives CaOH twice plus hydrogen. Hydrogen gas burns with pop sound and blue flame. Third method is by the action of water on soluble metallic oxide. As I told you in the previous video that non-metallic oxides are acidic in nature, whereas metallic oxides are basic in nature. For example, Na2O is a metallic oxide which when dissolved in water form a base NaOH. Same way, potassium and calcium also when dissolved in water forming KOH and calcium hydroxide. Fourth method is by double decomposition. Aqueous solution of salts like FeCl3, CuSO4, AlCl3, they combine with bases strong alkali NaOH and a weak alkali NH4OH, resulting in another basic hydroxide. For example, in iron it forms FeOH thrice, in copper CuOH twice, aluminium AlOH thrice, plus normal salts are formed. This reaction is based upon double decomposition, and students, if you remember, we have done in chapter number 4, that is analytical chemistry. It is same. The reaction or the use by NaOH, that is strong alkali, and the use of NH4OH, that is weak alkali, resulting in the formation of a base. Fifth method is by the action of oxygen on the metal sulfide. Metal sulfide like zinc sulfide combines with oxygen forming metallic oxide, that is ZNO plus sulfur dioxide gas is released. Same way, PbS plus O2 gives PbO plus SO2. And students, this reaction is also known as roasting, in which sulfides are heated in the presence of oxygen, resulting in the formation of a base and a sulfur dioxide gas. Next method is by the decomposition of salts. Salts like carbonates on heating decompose to give us basic oxide, along with that carbon dioxide gas is evolved. For example, CaCO3 on heating gives us a basic oxide CaO and CO2. Same way, CuCO3 also decompose to give CuO plus CO2. And how to trace the presence of CO2? A brisk effervescence is formed. Effervescence means gas bubbles are released, which shows the evolution of CO2, and it turns lime water milky. Students, an important note here, sodium and potassium carbonate do not decompose on heating because they are stable to heat as they are highly reactive and present at the top of the activity series. Their decomposition is possible only by passing electric current, and students, that we will do in detail in chapter electrolysis. Now, second is decomposition of nitrates. Nitrates decompose on heating to give us basic oxide, along with that reddish brown gas NO2 and oxygen gas is released. For example, CaNO3 twice calcium nitrate on heating decompose to give us a metallic oxide, that is CaO plus NO2 plus O2. Same way zinc nitrate also. Students, one important note here, sodium and potassium nitrate do not give metallic oxide when decomposed. They result in the formation of nitrites. Now let's take an example. Potassium nitrite, for example, on decomposition, on heating, gives us KNO2 and along with that oxygen gas is released. Same way, sodium nitrate also decomposed to give us sodium nitrite and O2. Sodium nitrite, that is NaNO2. They never decompose to give us metallic oxide and NO2 gas due to their high reactivity. Last method of preparation is of ammonium hydroxide, a weak alkali. How it is prepared? It is simply prepared by dissolving ammonia gas in water, resulting in the formation of NH4OH, that is a weak alkali. It is also known as aqueous ammonia. Now students, come to the next topic, that is properties of bases. First, physical properties. Number 1, they have a sharp and bitter taste. They are bitter in nature. Number 2, they change the color of the indicator as we have done in acids. There are 3 main indicators: litmus, methyl orange, phenolphthalein. Litmus paper changes from red to blue, methyl orange, orange to yellow, phenolphthalein, colorless to pink. Now let's perform a simple experiment, students. This is a bottle of phenolphthalein, which is an indicator. Then methyl orange, this is also an indicator, and a litmus paper, blue litmus solution. So in this beaker, I have taken a base, that is a strong base known as sodium hydroxide. I'll take a litmus paper, that is a blue litmus paper, and dip in this red litmus paper and dip in this basic solution. The red litmus paper will turn blue. Students, you can see the color of the litmus paper. It changes to blue, showing that it is basic in nature. Now we will put phenolphthalein solution, another indicator, to this solution. The color of the solution, it changes to pink, showing that it is acidic in nature. Now let's take another beaker containing sodium hydroxide solution. We will add third type of indicator, that is methyl orange. The color of the solution, it changes to yellow. You may see here the color is yellow. It changes to yellow when we add methyl orange, showing that it is basic in nature. So these 3 indicators help us to distinguish between acid, base and salt. Now come to next physical property, third one. They are soapy substances, that is slippery to touch. Now what is the meaning of this line? Caustic soda solution, that is NaOH, and caustic potash solution, that is KOH, both are strong alkali. And there is a property of alkali that these alkali reacts with oil to form soap. Since our skin contains oil, that is fat, hence when we touch the base, that is caustic soda or caustic potash, a reaction takes place and the soapy solution is formed between our skin and the base. Fourth point, they are strong electrolyte. Now what is the meaning? Let's take an example of NaOH. NaOH in the aqueous form dissociate to give us Na positive and OH negative. As ions are produced, so we may say they behave as strong electrolyte, which is responsible for the passage of electric current. Now last physical property is they show a mild corrosive action, that is slight burn is there on the skin. It is less corrosive than acids. So students, this finishes with the physical property of bases. Thank you.